Hello everybody. Last time we had some relaxing time with challenge math problem 89 because it was a very simple right triangle application Pythagorean theorems, right? So today the question is here: what the radius of a circle S? Many of you already got the answer, I think. Okay, so this time again, because we got at least one information of angle, and then you connect here. Then these plus that make 90 degree. Okay? This plus that make 90 degree because this one is perpendicular. Okay? So we can make equation here. Let's say this one is 1, side 1, and the side 2, and the side 3, and the angle, this one make an angle 4. Okay? Then 1 square equal 2 square plus side 3 square minus 2 times side 2 and side 3 and the cosine of angle 4, right? So in this triangle again, you just define each side. Well, of course, you have to include R, okay? Then we just get some information or simplify or whatever way, then you can see. Once you write down, you can get some idea what to do next step. Okay? So, okay, let's open next page. And what to do? You remember this graph, okay? This graph. Here you have center of the greatest circle is a P, and then center of a second greatest circle is a Q, and then R and S like that. Then, what kind of equation can you make? Okay, let's see. Here, angle QPR is a beta, angle SPR is a alpha, and alpha plus beta is 90 degree. You remember, okay? Means here, this angle together is 90 degree. Or you may use later alpha equal 90 minus beta. Okay, let's see what kind of equation can we make. Okay. Now you look at here. PR is 20. PR, you remember, P was the center of the biggest circle, and the R is the center of a semicircle at the corner, and the QR is 25. This means the radius of second biggest circle plus radius of another one, and then alpha plus beta is 90 degree we have. So one side is square. It means the opposite side of angle alpha, opposite side, okay? At least we know one angle information and two sides. Then we can use a log cosine, okay? Remember. So side square plus side square minus 2 times side minus cosine alpha. Exactly the same. Opposite of angle square equal side square, you add and then take out 2 times of each side times cosine of beta. If my lecture is too fast, you rewind and check and study again. Okay? So, in the same way as 89, in this case also, from equation 2, this one we rewrite r equal something. And from here also r equal something boom. And then we equate two expressions. And then whatever unknown value will be solved. Okay? Do you remember these are two equations? And then we go over here. As we expected, from equation 2 we got r, from equation 3 r, so r and r same, so two of them must be equal each other. So we equate and then we replace the alpha by 90 degree minus beta, and then you solve for a cosine beta first. Okay, this was the step 1. Once you get value of cosine beta, remember cosine beta itself can be one unknown value. And then after that, you get value of beta as a second step. Once you get value of beta and cosine beta, or without getting the beta, probably you can replace this one into here directly, right? Then you can solve for r. Okay, using a scratch paper, when I calculate, value of r came out 5. Value of r came out 5. Okay? If you have any question, rewind my video and study again. Okay? And the next time I will go over another one. This one is a little different from know your questions we covered so far. Okay? In this question, let me read the question first. Okay? In the figure above, radii of a circle A, B, and C are 6, 4, and 2 respectively. Okay? It means what? This radius is 6, this radius is 4, and then this radius is 2. Then the question is, when 3 circles attend each other, and then inside I have a small circle here, and then what is the radius of this small circle? There's a question. Okay, now, when you connect those 3 points or whatever, okay, we don't have any idea about the angles of each side. No matter what kind of triangle you make, we don't have any information of angle. Okay, then what kind of equation we're going to use? So you have to get some idea. Okay, so normally when you have a triangle, very first step, right triangle application, and then secondly, when you have a triangle, at least we know one angle and the two sides, any two sides with one angle. Okay, with two sides, with any angle. When you have one angle and any other two sides, then we use law of cosine, then we can solve it. Now, when you have a triangle, we don't have any idea here, we don't have any idea about angle, and we don't have any idea of angle. In this case, another tool will be Heron's theorem. Okay? Only with the three sides known without having any information of any angle. Then you use Heron's theorem or Heron's theorem. Okay? Either way, same one. Okay? So you study this one first, or like a long time ago when I give you lecture on figures, one time we studied that, but I don't think all of you saw my lecture at the time. So you find the Heron's theorem, okay? And then you apply the set equation to get radius of a circle of D. Okay? Okay, see you next time. Thank you for your watching my video.